Hi everybody. This is, well, I have it labeled here as video 0 for module 6. It's actually an addendum to this week's lecture. I'm not exactly sure how I forgot to do the finale here, but I did, so I decided I would add it as a precursor to this week's video module. So in the lecture, what we ended with was the table structure, and we went through the design process and to develop this table structure. And what I didn't really do is to kind of finalize, well, why is this important and how is it useful? So I just wanted to spend a couple minutes talking about that. So remember, we have the materials table, which is linked to the routing table, the bill of materials table, the resources table, which is used to auto-generate the object instances, and then finally we have the orders table, and it's orders that we're actually processing. So the important part here is to recognize how these table relationships and the table structure form the backbone of the model. So if we think about centering on the materials, we have a material name, which is the primary key, and that links to the routing table. So the routing table is a foreign key, and so with a sequence destination property. And so that means whenever an entity hits a route by sequence node, it increments the row reference in the routing table. The routing table then has a link or connection through the routing key to the bill of materials, which then gives the materials required for that particular step in the sequence. The resources has this dash link, which means the node is a component of the resource, and so that actually says which resources does the sequence lead to. And again, the resources tables auto-generates those instances. And finally, we have the orders table, where an order is for a particular material, and once we have that connection, when an order arrives, we know the material. We then automatically know the routing and can implement that routing through a route by sequence. And when we get to the individual step in the routing sequence, we then know the bill of materials, corresponding resource, and so on. So if you look back, let's look at the finished model. So here's the finished model that we're going to develop as part of this video module. Just run it for a little bit. You can see we have kit, assemble, finish, and package, as we mentioned. I have a couple of status plots showing the material status and all of that, but that's really not what I want to talk about here. We'll talk about this in this video module, but I want to go look at our data and look at the implementation of those tables that we design. So let's start with the materials table, and again, it has this detail view here with the connected tables. So let's look at module B, for example. And if I look at that detail view, I can see here are the routings. So module B goes from the arrival to kit to assemble to finish to package to ship, and these nodes are all corresponding to object instances that were auto-created. Then if I open the routing key, then I have the bill of materials. So when an order arrives for a module B and hits this first route by sequence right here, what that does is it increments the routing to this first row, sends the entity to kit, and within kit, we then have the bill of materials of component A, 1 unit, component C, 4 units. Next, when it finishes at the kit operation and hits the route by sequence here, it increments again and goes to assemble. Well, assemble doesn't have any bill of materials, or there are no raw materials required for assemble. If I can make this a little bit bigger. And so then it hits the route by sequence from assemble, goes to finish. Finish then has the paint. The paint is though linked back to the order table, and finally goes to package, where the raw material, let's see if I can make this. I can't. Let's see. Not able to make that. Oh, there we go, for box B. And so you can see how the table linkages facilitate the execution of the module. Of the model. And so then go back and think about how this works once we have this structure in place. In particular, let's think about two things we might want to do in the future. One is adding a new product, and the other is adding a new color. So if we add a new module, so we have module A, B, and C, here's what we have to do. We have to add a new materials record for the module, let's say module D, for example. Then we have to add any new material records for the raw material. So in other words, if we have something other than component A, component B, component C, component D, if we have new components, for example, we have to add those records into the materials table. Also, if we have a package, so if we have a box for that, a dedicated box for that, we have to add that too. Note when we add these records to the materials table, it auto creates the corresponding materials records, materials elements in the model. Then we add the routing records for the new module. So we just go in that routing table and say, goes from kit to assemble to finish to package to ship, assuming that that's the sequence that it follows along with the other modules. Then we add the bill of materials record. So once we have the routings, we can then link those bill of materials to the individual routing steps. And that's it. And so they're just data updates. We haven't made any changes to the model logic or the underlying code or processes or anything. All we've done is added data, and we've implemented this new module. Similarly, if we want to add a new paint color, so we started out in our model saying we have red, green, blue, yellow. Suppose we want to add a new one like orange, for example. What do? Well, we have to add a new material record for the paint. So for example, paint orange. And as with adding a new module, when I do that, it auto creates that material element. I then update the module color string list. So the module color string list is what we use to do the sequence dependent setup. And when we do that, it automatically changes or adds the corresponding row and column to that sequence dependent changeover matrix, which you'll see later on when you implement that. Then update the values in that matrix to say, for example, well, what's the changeover when I go from orange to red or red to orange or orange to yellow or yellow to orange and so on. So we just update those records in data and we're done. Then we can then purchase or add order records for modules in that color. And as with adding a new module, this is just data updates. We update the material records, the string list, and the changeover matrix, and there's no changes to the model logic or code. And so that's really one of the more powerful features of having this data-generated, data-driven modeling paradigm, and also the importance of having a strong the importance of having this table structure and understanding what that is and being able to and keeping this for future model updates. When we add functionality to the model, we're going to be updating this basic structure. And that's it. That's what I forgot to say during this week's lecture. So now you can carry on with the video module.